Right, hello and welcome to this video. This is a tutorial on the second part of differentiation for C2. Now this installment is purely about damn it, I'm not very good at this. What's it called? Optimisation. That's it. I mean, you can't spell, but I can do the math. So, optimisation, what is it? Well, we've looked at in the previous video at the basis for differentiation in terms of the context of is it a maximum or is it a minimum value in terms of the curve, and we also looked at just differentiating, finding if it was as I said, a maximum or a positive. Maximum or a minimum, sorry, of the curve, and if how to calculate the stationary point on the curve in terms of finding the x and the y coordinates. We're going to take it up a little bit here. Now, optimisation, what is it? Well, we did look at differentiation, as I said. This part of differentiation is looking at the real-world applications of it, so it's a bit more, a bit more useful. This, what it looks like on the board I've got here, it looks like a very basic shape. All we've got here is essentially just a block with an x and 2x's width, and a volume we're given at the top. We're told x is between 1, 2, 3 or 4, as it's not including 0 or 5. So it all seems very basic. And now, the first thing it's asking us to do is find dv by dx. What that basically means is differentiate the equation in terms of the volume. Is it dv by dx? Yeah. So, this equation here, 4x, in brackets 5 take x, and you square it. We need to expand this, so I'm going to rub that dv dx off because we're going to need to expand the volume bit here. So the volume is originally equal to 4 brackets 5 take x squared, 4x take, So what we need to do is expand this. So 4x, 5 take x, and then do it again, 5 take x. May seem very basic, but we've just got to do it. 4x brackets 5 times 5, 25, x times x plus x squared, negative 5 times x plus negative 5 times x, and a total minus 10x. So that is your total volume equation. So what we need to do with that is we need to expand this. So 4x is 100x plus 4x cubed plus take 40x squared. So that is essentially our expanded volume equation. Get rid of that line there. This is the expanded one you need to focus on. Now to do dv by dx, what we do is we raise the power and then times it to get rid of it. Basic differentiation. So that just becomes 100 plus 4x cubed, 4 times 3 is 12, reduce the power, plus is x squared, minus 80, 40 times 2, reduce power, that's your dv by dx. So that's all it's asking for the first one. That's the first part of the equation done. It doesn't look too much as though we've actually real world terms of applicated it, but all we've done is found the volume, and that's just the equation it's given us. It could be anything, but as long as it equals the volume, that's what it's given us. So the next question is find the maximum volume of this box. So what we need to do, when the maximum volume, the dv by dx equals 0, is basically the same as the maximum point. So if I won't draw it, but you look crazy, you deserve this. I'll put it in a different colour actually, because it's not part of my working out. You shouldn't be drawing this. But just to confuse you, I'm going to draw it. Get rid of the banter lines. So, I don't know. this is a really rough estimation of the curve, which is why I'm not expecting you to draw it, because it'd probably be wrong. But this is just a curve, it's not the curve, yx, and it's going to be an x cubed graph, so it's going to probably look something like that. And obviously that's a maximum and a minimum. Actually no, there's pointless me drawing that because I've just confused you actually. So basically, the maximum point on the curve is basically like a flat line. So dv dx is a gradient function, so it equals 0, which is a topic we discussed in the previous tutorial, which is why I separated them. So you can look back to the other one, or listen to them at the same time even. Imagine that. So, it says that what we need to do to find the maximum volume is we need to, this is our volume equation at the top. I don't know if you can see that. Right, so we've got our volume equation at the top here. You see 4x brackets 5 take x squared, and what we're trying to do is we know at the maximum volume it can't increase its volume, so the gradient is going to be 0. It's going to sort of flatline, if that's not offensive. So dv dx is going to be 0 because that's a gradient function, and essentially the gradient function of the line. So if we put 0 here, what we're doing is finding what x is, so we can put it back into this equation. But it says here x is between 0 and 5. So we know x is going to be 1, 2, 3, 4. And obviously they could be integers, they could be decimals, which is going to be, but you shouldn't. So 100 plus 12x squared, it doesn't matter which way around you write this, as long as you get the pluses and minuses, adds and takes, whatever you want to call it, the right way around. As long as you do that, it's fine. Basic primary school stuff, but never mind. And if we could divide this all by 4, because 4 goes into all of them. So 4 goes into 100 25 times, so 25. It goes into 12, obviously 3 times, so it's going to be, we're not taking out an x, so it's still 3x squared. So take, sorry. Just as I say, I mess it up. But I managed it. So 4 into 80x is 20x, and that's your equation. But, as I'm going to rub this line out again, I'll just get rid of it. What we're going to do is we're going to simplify this down, because now we've gone into an x squared, it is quadratic, so we can simplify it down. Sorry, I'll get out of the way. Oh gosh, my knees. So 4, and we could have 3x, and in brackets we could have x again, minus 5, and minus 5. Oh damn it. Now if you don't believe me on that, you can obviously, good idea to see for yourself by expanding these brackets, times it by 4, it should get you this equation up here. So, what can we deduce from this? Well, x is either 5 or x is equal to 3 over 5. Oh, is that the way around? Oh no, 5 over 3, sorry. Round. Now it tells us up there, sorry I'm getting out of the way a little bit, it tells us it's going to be 1, 2, 3 or 4. So that means it can't be 5, as by power of deduction and logic and being a human being, you know that 5 is not in that power, so and this one is. So that obviously tells you we're going to use that one. And if you wanted to do it on your calculator, this comes to about 1.6 I think. 1.6 recurring, but I'm just going to leave it as a fraction because it's a lot easier to use. So that's our x value, and it says the maximum volume. Now we know the volume is 4x, this thing up here. So what we can do is put this value into that one at the top. So the volume equals, now we know x is 5 over 3, or 5 thirds. So still put this in, 5 thirds, and then we put brackets, big bracket, 5 take 5 thirds, and we square that, and that gets you a volume of, let me just check, done this right, 74.07. And obviously you could round 74, but you could round that up to 74.1. But for accuracy, at this moment in time, I'm not going to round it up. And also, if you're a physicist, you don't round it up. See, I am. So that's B done, and you need to put centimetre cubed on the end of that. You could round it up in this sense for this question, but for the next question, for part C, you want to use that more accurate value, as it will obviously increase the accuracy of results in an exam. And you maybe round it too high, and it will increase your rounding error, and increase your random error, which is again about physics term in mind. So C, the last part of the thing, it says use calculus to justify the volume that you found in part A is a maximum. Now, when we talked about finding maximums before, we talked about differentiating twice so you get the second derivative. So if we differentiate twice, this is our old differentiation equation, the first one. If we differentiate that, so we're differentiating this equation here, we get rid of the 100, and then we turn it into a 24x, and obviously the 80x just goes to an 80. So we take away 80 from that equation there. So that gives us our second derivative. So that's same as d squared v over dx squared. So that's your second derivative. Now we know x is 5 thirds, don't we? We're not using the volume. We're not using the volume actually, because all we've done is find out the maximum volume, and we don't need to use it again. So it's asking us, how do we know it's a use calculus to justify the value that you found is a maximum. Now we said a maximum is going to be a negative value. So if our calculations are right so far, we're going to get a negative answer here, as the question is pretty much telling us that's what we should have. But if you didn't know that, you should have done. So 24, and we're just going to substitute x in. So 24 times our value of x, which is 5 thirds, take 80, and that should give us, if you do it on your calculator, I think it is 20 over 5, 24 over 5. So I'm just working out in my head. Over 3, take 80, 40, minus 40 I think. I don't know if I've done it right. You have to check that, but I think it's minus 40. That calculation's right, I'm just... Yeah, it's got to be right, because that goes into that so many times. Yeah, sorry. So it is minus 40. And now we can say, because that's a negative, I mean, even if your calculation was wrong here, and you got a positive, you know straight away you've done something wrong here. But you would still get the marks in the exam for saying, well, my value is positive, but if my calculations were right, I would have got a negative, and this would have indicated that we were at our maximum. And you would still get the marks for part C. You'd lose it for part B, a couple of marks for your calculation where you went wrong. But for part C, you would get the marks because you've proven to the exam and you know what you've done wrong. You know you've done something wrong, but obviously you can't figure out what you've done wrong. So as long as you've stated the fact that you know the maximum is going to be a negative value, so you get the marks. So as I said, negative value, that's good for us. So we know negative shows a maximum. And if you don't understand why, you can go back to our previous video. And that's, I mean, the main thing they're interested in is this part of the equation here. They're not really interested in this garbage here, but I've just put it there so you understand. It's just a bit more clear. Make sure you get them. I mean, they are going to be bothered about you putting that, but I don't think you'll get all the marks. But you get more marks for putting the calculations in this type of context, if you like. So that's pretty much it, actually, for optimisation. I will do a few more questions later on as we start to get through. Well, I'll do a few more calculations later on, but hopefully I thought that was one of the trickier ones. Well, tricky ones, but it was one of the easy ones to explain, I think, if you're trying to get it through your head. Just using bits of the information it gave us. So the first derivative is finding what x is, or is finding the solutions. So if you're doing it in the context of optimization, it gets you the value of x. But if you're doing it in the context of normal differentiation, it just gives you the value of the x's, x values intercepts on the graph. The second value, when you differentiate twice, it gives you if it's a positive, it's minimum. If it's a negative, it's a maximum, and it tells you the nature. The nature is the word they use in the exam for the kind of point on the curve that is. You won't get halfway if you differentiate it twice. So as I said, that's the basic stuff. That I hope that's helped in some way. Oh, actually, I don't know why I've drawn that. That's completely irrelevant, them values. I've just noticed that. Actually, you don't need them values. That's just a... Right, anyway, I'm wasting your time, so see you in the next video.